In this lecture, we're going to understand about the different methods of evaluation of limits. These methods are the evaluation for algebraic limits, and the methods are direct substitution, factorization, rationalization by using some standard limits, and methods of evaluation of limits at infinity. Let's see the first method, which is direct substitution. So there are functions like example. If we have limit x tends to 2, x squared minus 4 over x plus 3. Now such functions at a particular value is defined and continuous. Also, by substituting the value in the function, you don't get indeterminate form. So we can directly substitute the value, or we can plug in the value, and it will be 2 square minus 4 over 2 plus 3, and that gives you 5. 4 minus 4 over 5, that's 0. Here we are not getting any indeterminate form by substituting. So this limit can be solved by direct substitution. So in the direct substitution, limit x tends to a, f of x is equal to f of a. Another example. So if this is limit x tends to 2, 3 minus x, this is going to be 1, because 3 minus 2 is 1. Or limit x tends to 1, x square plus 1 over x plus 1, you get 1 plus 1 over 1 plus 1, that's 2 by 2, which is 1. So for the value, when you don't get indeterminate form, it can be solved using direct substitution. Now we'll learn how to find the limit using factorization. So if you have a function where you substitute the value of x and you get 0 by 0 or any indeterminate form, factorization is useful to find the limit. For example, x tends to 2, x to the power 4 minus 16 over x minus 2. So here, if you substitute x with 2, you get 0 by 0, which is an indeterminate form. So we factorize the numerator, which is x square square minus 4 square. And here we can use the identity a square minus b square, which is a plus b, a minus b. So then it's going to be x tends to 2, which is x square plus 4, x square minus 4 over x minus 2. And again we can factorize, because x square minus 4 can be written as x plus 2, x minus 2, using the same identity which we used in the previous step. So which is x minus 2, we can cancel out x minus 2 and x minus 2. And now, because we have simplified using factorization, if you substitute x with 2, you won't get 0 by 0 or any indeterminate form. So this is 4 plus 4 and 2 plus 2, which is 8 times 4, which is 32. This is how we solve the limit problem using factorization. The second one, which is x to the power 3 over x plus 1. And this is limit x tends to negative 1. Here too, if you substitute x, you get 0 by 0. So in the numerator, we use the identity a cube plus b cube, which is a plus b, a square minus ab plus b square. So that's limit x tends to negative 1, x plus 1, x squared minus x plus 1 over x plus 1. We can cancel out x plus 1 and we get limit x tends to negative 1 x squared minus x plus 1. Now we can directly substitute the value of x. It's negative 1 square minus 1 plus 1, which is 1 plus 1 plus 1, and the answer is 3. Let's solve together the third problem, which is x square minus 4x plus 3, which is x square minus 4x plus 3, x square minus 2x minus 3, and limit x tends to 3. Here too, if you substitute x with 3, you get 0 by 0. So we use the method of splitting the middle term and will factorize both numerator and denominator. And it will be x square minus 3x minus x plus 3. And we split the middle term, x squared minus 3x plus x minus 3. So the factorization of numerator would be x minus 3, x minus 1. And for the denominator, it's going to be x minus 3, x plus 1. We can cancel out x minus 3 from the numerator and denominator. And now we can substitute the value, which is 3 minus 1 over 3 plus 1. That's 2 over 4, or we can say 1 by 2. You can practice with me, you can pause the video, then you can try yourself. And this is x to the power 3 minus 125 x square minus 7x plus 10. We'll factorize both numerator and denominator. In the numerator, we'll use the identity x cube minus b cube, a cube minus b cube, which is a minus b, a squared plus ab plus b squared. And in the denominator, we'll split the middle term. So this is x cube minus 5 cube. And in the denominator, we'll split the middle term. And we'll write it minus 5x minus 2x plus 10, which is limit x tends to 5x minus 5 x squared plus 5x plus 25 over x minus 5 x minus 2. We can cancel out both x minus 5 here. And now we can directly substitute the value of x to get a real number. So this is going to be 5 square plus 5 times 5 plus 25 over 5 minus 2, which is 25 plus 25 plus 25 over 3. That's 75 over 3, and that's 25. 25 is the answer. Right. Let's solve another question. Here we have limit x approaches to 0, 2 plus 3x whole square minus 1 plus x whole square. over 6x. So in the numerator, we're going to use the formula a squared minus b squared, a plus b, a minus b. But before that, we need to simplify, and this is going to be x tends to 0, 2 plus 3x 0, and we can write this as 2 plus 2x squared. And now we can use the identity. So it's 2 plus 3x plus 2 plus 2x, and 2 plus 3x minus 2 minus 2x over 6x. So here this positive 2 and negative 2 will be cancelled out, and by simplifying we get 5x plus 4 times x over 6x. We can cancel out x here, and we get limit x tends to 0, 5x plus 4 over 6. And here we can substitute x with 0, we get 4 over 6, which is 2 over 3. This is how, by using factorization method, we can solve the problems of limits.